Assalamualaikum warahmatullah and a very good morning to all. Alright, so we look at the format of ujian amali science physics. Alright, so I'm using the question that I just share in Telegram group. You can download the soft copy lah. Alright, so when you receive your question paper, read carefully. Carefully the instruction. Alright, so this paper is a 45 minutes paper. 45 minit. Okay, you read the instruction carefully. The total marks for this paper will be 15. Okay, 15 marks. You need to answer all the question, jawab semua soalan. Then you need to write your answer in the column provided in the question paper. Show the calculation, the step, and then the diagram is not in scale unless stated. Okay, and you will be given 5 minutes to check the apparatus before ujian amali science. Alright, yeah. Okay, we look at the second page. So here. So in first 5 minutes, okay, you are required to check list of apparatus and material, read question and plan experiment. So these are the list of apparatus material you check in your tray. Okay, read carefully, check carefully. If you have the correct quantity, then take just like this. Plywood with that dimension 3 cm times 3 cm 2 plywood. So if you have it in your tray, just tick. Okay, meter rule, if you have it, just tick like that. Okay, if let's say protractor is not in your tray, so this one you can put up your hand lah. Ask from the lab assistant or ask from the teacher in charge. Okay, now after you finish checking, wait, if let's say you have just like this, like stopwatch, make sure you check it is function. Insert the battery and check, make sure it can record reading. Okay, same goes to, let's say, battery, dry cell and so on. So make sure it works. Okay, if it does not work, ask from the teacher in charge lah. Alright, we look at the question. So you are required to carry out an experiment to determine the value of gravitational acceleration G using simple pendulum. Okay, so they give you diagram. This is a guided experiment lah. Okay, hopefully you get a guided experiment. Okay, now so the length of the pendulum bob, okay, clearly shown here, is measured from here to the center of the pendulum bob. Okay, so make sure you measure like that lah. Okay, alright. Then this is the amplitude. They show the angle here. So this is the equilibrium position, and then you pull. This is the angle, the amplitude. Okay, we need to further reading first. It means that now you have 2 plywood, so your string should be insert in between the 2 plywood. What I mean is like this. Let's say this is 1 plywood. Okay, another plywood. So the string should be in the middle here. So here you clamp lah. Pendulum bob like that now. Okay, in the first 5 minutes, just read. You cannot hang your pendulum and so on. Okay, just read the question and plan. Okay, so carry out the experiment using the step below. Okay, arrange apparatus by placing the thread in between, here mentioned clearly, in between 2 plywood that is clamped by retort stand. Okay, as above. And then measure the length of pendulum L, 30 cm, from the center of the bob to the point of suspension using meter rule. Okay, 30 cm. Then after that, Okay, displace the pendulum by 10 degree and release the pendulum. Record the time taken for 10 complete oscillation T and calculate the period of oscillation using that formula. Can see the formula? So we have T, capital T, small t divided by 10. So you calculate T square. Alright, then repeat step 1 to step 5 using L 40, 50, 60 until 70. Okay, now, so you better read all, okay, because from here you can see that after you do for 30 cm, just now said 30 cm right here. Here, 30 cm. After 30 cm, then you need to repeat 40 until 70. So, to save your time, you better do like this. Pendulum bob. Okay. Already tied with a string. Let's say this is a string. Alright. Then let's say this is your ruler. Alright. So make sure the string is parallel to the ruler and you can mark earlier. Okay. So from the center. Okay. Make sure betul-betul. Jangan salah this one. Carefully. Center. Okay. So you measure 30 cm. Let's say this is 30 cm. So you mark here using your pen 30 cm. Then you quickly just mark 30, 40 here kan, 40, 50 and so on. Just mark 40, 50, 60, 7 and so on. Then only you hang your pendulum using in between the two plywood. Okay, after you mark this, so that you don't have to keep on take off the pendulum and then measure again. Okay, all right. Okay, so you start with 30 cm. So this one is 30 cm. First reading 30 cm. So you displace the pendulum, all right, until you put your protector like this lah. You put your protector like this. Make sure here is 0. So then the angle here, jangan salah angle 10 degree. Okay, pull 10 degree. Maybe here is 90. So means that here will be 80 lah. So that the angle in between is 10 degree. Okay, check your protector. Alright, so you release and make sure your pendulum stable first before you start taking the time. Alright, so record time taken for 10 complete oscillation. Okay, then after that you need to calculate T and T square. Okay, first question. Based on the experiment conducted, state the responding variable. So this question, this one, responding variable, manipulated, responding, you can get it earlier. Means that before you start doing experiment already you know already. So here, manipulated is this. When you see the word repeat, this is manipulated. Means that L is manipulated. But the question did not ask for manipulated variable. Kan? No. So, manipulated variable, if asked, is this L. What is L here? This is manipulated variable. Responding variable in this case is here. They give you this T. Okay. Period of oscillation. We can write period of oscillation here. Responding variable is period. Period of oscillation. And then it's good to write symbol T. You can copy this. Copy from here. Okay, next. Tabulate your data for the value of L, T, capital T, T square. So you see here we have how many? 1, 2, 3, 4. Means that you need 4 columns. So make sure you draw your table. Make sure have table. If you just write L, T1, t square, there will be no mark given for you. Hilang lah this 6 mark. Alright, so make sure you draw your table. What I mean is like this. Okay, draw your table. Make sure you have like that. Okay, so the value of L, just copy here. And then the value of T1, this is what you get from your experiment lah. Okay, it should be 2 decimal place. Okay, stopwatch, 2 decimal place. And then T will be, you can follow the same decimal place as this reading. Okay, and then T square will be same decimal place as this reading. Alright, so don't forget unit. So L will be centimeter, T is second, here also second, but T square will be T square will be second square. Okay, so I show you the marking schema. Here. Okay, make sure you have the table. At least you have this lah. At least you have, when you draw table, at least you have this border. Katakan tak sempat lah, at least you have this. Alright, at least that. But kalau sempat, then don't draw this like this. So individual line here is not needed lah. This one no need. Tak perlu. Okay, don't waste your time. But make sure your handwriting, there is a distance between each row. Alright. So how do they give mark here? This is 6 mark. So you can see here. This is how normally mark is given. So table lah, see here. Show table. Mesti ada table. Means that you have the border lah. Show table. Means that you must have the border of L, T, capital T square. So that will be 1 mark. Okay, you have the table. Okay, you draw the table, and then you have this. I better use color lah. Alright, 1, 2, 3, 4. With the green border, that will be tick 1. Okay, tick 2. What is tick 2? Tick 2 is unit. Here, state the unit of L, T, and T square. So unit, you must have this. Centimeter here, S square. Then you get tick 2. Alright, tick 3 will be the value of responding variable. Here. The raw data that you collect. T, all in the range. They have range actually. Here should be 2 decimal place unless you use a manual stopwatch. Okay, manual stopwatch will be 1 decimal place. But if let's say the digital stopwatch will be 2 decimal place. Okay, alright, that will be tick 3. And then tick 4, what is tick 4? Value of T. Value of T, all value of T correct. That is tick 4. Okay, correct decimal place also. And then T square will be the value of this, you square it. So means that you use your calculator lah. 1.10 square, write the value. Okay, make sure you don't do like this 1.10 square, salah ataupun put 1.26 square. Why? Because you get it from here, right? Tapi this is, don't do like this. Just use your calculator, write the final answer here. Okay. Alright, that will be tick 5. Tick 5. All T's correct. Alright, tick 6. Tick 6 will be consistent decimal place for T, capital T and capital T square. So means that here the number of decimal place all consistent. So you get tick 6. So all together is 6 mark. Sudah, Alright. Alright, after the table, you need to plot your graph. Physics question is always like this. Okay, normally you will ask to do experiment, write your data in table, and then plot your graph. Graph of T square against L. Alright, T square against L. Remember, the first variable mentioned, this must be the vertical axis. Vertical axis means that t square should be like that. And then the second variable mentioned should be on the horizontal axis, L. So from here, actually, we also know that this is your MV. Means that the second here is manipulated variable. The first mentioned is actually responding variable. Alright? Boleh ha? Alright, plot your graph. Then after you plot your graph, okay, they give you the relationship between t square and L given in formula form. Then from your graph, you need to calculate the gradient of t square against L. Okay, we plot the graph first with the data given. I just show you the marking scheme lah, huh? Alright, so this is the graph t square against L. It is a straight line graph from origin, so this is a directly proportional graph. Huh? Alright, when you plot your graph, don't forget this here 0. Start from 0. Don't cut the axis. And then make sure the scale that you choose, okay, let's say you don't have reading, just like just now, right? Our reading start from 30, right? 30 cm. But 10 and 20 must be in your graph. Although you don't have reading, okay, don't cut the axis. What I mean is, you don't start with 30 here. Okay, 30, 40, salah, ha? Understand, ha? You cannot do like this, ha? Salah. Must start with the uniform scale lah. So the different here must be the same. This is 10. This is also 10. This is also 10. Kan? Boleh faham, ha? Right? And then here you see 0.25. Here also 0.25. Here also 0.25. 0.25. Okay? Jelas, ha? Alright. So you transfer your data. Then draw the best fit graph. Best fit graph means that the graph does not need to go through all the point, but as long as the number of point above and under your graph is nearly the same, that is good already. Just like this. The graph, when I say graph, I'm talking about this line. The graph go through 1, 2 point. This is under the graph. This is look like macam under the graph also. This one is above a bit. So you have 1 up, 2 down. That is a best fit graph. Okay. And then when you label the axis, make sure you have unit, t square just now. And then s square. Here also, just follow the table. L centimeter. Okay. Dah, I rub this off first. Okay, how the mark is given. So graph is only 3 marks. You see, there will be 7 ticks given on your graph. There will be 7 ticks. So if you get 6 to 7 ticks, you will get 3 marks. If 4 to 5 will be 2 marks. If 1 to 3 ticks, you get 1 mark. Quite easy to get 1 mark, okay? 1 tick is 1 mark already, like they say. Show t square on vertical axis and L on horizontal axis, already get 1 mark. If you do like this, we katakan, let's say you don't have data, but you just draw this, this is already 1 tick, means that you already get 1 mark. Here, 1 mark. Terus dapat 1 markah, 1 tick. But let's say you add in, okay, tambah unit, right? State unit. Kejap, T on the vertical, L on the horizontal is the first tick. Unit means that you add in here s square, here centimeter. That is the second mark. Second mark already, 2 tick. Alright, bukan second mark, 2 tick. Tick number 2. Now tick number 3 is here. Both axes are marked uniform scale. Quite easy to get that. So at least try this. At least 3 point plotted correctly. Tick number 4. All point plotted correctly. Means that if all point plotted correctly, you already get double tick here. So means that all point transferred correctly get 2 tick, plus all of this just now 3, already 5 tick. 5 tick already get 2 mark. A bit more. Then draw the best fit graph. 6 tick already get 3 marks. Okay. Alright, then the size of your graph should be as big as possible lah. Here, at least 2 cm times 2 cm. What we mean by graph is the here, this one. This is your graph. 2 cm means that one will be varies. For me, it's just draw the big graph that you can. Okay. Alright, next question. It asks you to determine the gradient, right? Gradient. Now, calculate the gradient. How much is the mark? 2 marks. 2 marks gradient. So gradient, you must draw the this triangle. Kejap, triangle. Gradient, you draw the triangle here. Right, the right angle triangle. And then this point does not need to go through the point that you plot. You can also draw your triangle from here. Any point that is clear reading, just like this, you can start from here also. This point. Here also can. Pull it to the horizontal axis. Okay. So this is considered as big triangle. Okay. This is the first tick for the gradient. Then it's good to write the coordinate here. What is the coordinate here? Let's say I just put here as x, y. Here will be another coordinate 0, 0. Alright, so gradient. Okay, but need to write in the column provided. So gradient, what symbol do they use? Good job. Oh, they don't give any symbol. Determine the gradient. Sometimes they do like this. Calculate the gradient, comma, m of graph t squared against L. So m, let's say I just add in m lah, equal to, it should be y minus y1 minus y2, or the other way around, x1 minus x2. So you have 2 coordinate just now, which is, katakanlah I simply give number. Where is it? Kejap. Let's say we use this point. So this one is 2.25. So here y is 2.25. Hey, why my ink tiba-tiba hilang? Oh, alright. So here, alright. So coordinate here is the y is 2.25, x is here. How much is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So means that this is 55 lah. 55. So the coordinate is 55, 2.25. Okay, so I write like this. 55, 2.25. Okay, so gradient, I write here lah, gradient. Gradient is equal y 2.25. This is y1 lah, y1 x1 minus, where is your y2? Here 0, 0, 0. So mesti tulis although it is 0 divided by x 55. Also need to show this. Okay, you calculate. This is another mark. Okay, your final answer, correct unit. That will be tick number 3. Okay. Alright. Now, what is the unit? Unit will be up here. vertical axis, y. So it should be S square. Horizontal axis, check here, centimeter. Alright, so you calculate. Make sure your answer have about 4 decimal place. Then the unit is S2 cm minus 1. Faham? Okay. Like that. See? So this is the substitute value just now. And then this, you see, 4 decimal place. Oh, this one, 4 significant number. Alright. And the unit is S square cm negative 1. So write more decimal place is safer lah, lebih selamat. But for me, it's at least 4 decimal place. 5 is good. No? Okay, next. Next question. They give you this formula. T square 4 pi square L over G. Okay. Now, this one I just copy paste just now. The formula here, this one, I copy paste from the previous page. So using the gradient that you already get just now, determine the value of gravitational acceleration G. State your answer in SI unit. Okay, now you need to determine this G. But you need to use the gradient. So how? Okay, you cannot simply add in values. If you are not careful, you might just get the reading from your table. Salah, huh? You cannot. Can your table have T square? Your table also have L. Some of you might just use T square and L from one row of your table. What I mean is like this. Some of you might do this. Here. Kan ada banyak, right? You have 1, 2, 3, 4, 5. Maybe you use, L 70. Your T square is 2.86. Salah, huh? Cannot use this. You need to use the gradient. How? Alright. So gradient just now. Okay, gradient. Gradient, I just use symbol M lah to make it easier. You can also add in symbol like that lah. Okay, gradient M is equal to vertical axis. Your vertical axis is actually T square. Okay, changes of the vertical axis divided by changes in the horizontal axis. Your horizontal axis is L. Okay, that is your gradient. So from here, can see this is T square. And then you can see L. You try to change your equation so that you can see this in your equation. You can see this one. Because that is equal to the gradient. So to have this form, this L must be moved to the left. Then you will see this form. Okay. What I mean is like this. Alright. So you have T square divided by L. So equal 4 pi square over G. When you write like this, can see already this is your gradient. This one gradient. So you use the value that you have just now for the gradient. Where is it? Here lah, huh? We use this value lah, huh? This gradient 0.04086. Okay, so here the gradient. This is gradient, means that gradient is equal to 4 pi square over G. So substitute 0.04086. Betul kah? Betul. Okay, equal 4 pi. Pi you can use your calculator lah, huh? If not given, they don't give. Use your calculator. And then G. Like that. But the unit now is in, what unit is this, huh? Second square. Kejap. But the unit now is second square centimeter negative 1. G, when you calculate like this, your G will be still not in SI unit. You need to change this. Divide by it's actually you can change it earlier. What I mean is here, here, actually here, before you use this data kan, okay, you change from here. What I mean is if you are not sure, you can do 2.86 divided by 70 centimeter times 10 negative 2 lah. So you get your answer in S square meter negative 1 like that. Okay, here see, in meter. Alright, boleh ha? Then the answer will be in meter per second per second. Alright, next question. Okay, kejap. This part, you can also just write like this first so that you still can get 1 mark here. Okay, then you try to substitute, change the centimeter so that your answer, your final answer will be in meter second negative 2. How come like that? Because G now is here, right? If you bring G up, this one will be bring down, so the unit become opposite lah. Okay, you try first. If not sure, then ask again. Alright, next question. This is the last question. So what happened to the period of oscillation of pendulum if experiment is carried out on the surface of the moon? What will happen? So for this question, you actually can use this formula to predict. That is a prediction lah. Yeah, normally have question prediction like this. What do you think? What will happen? So in on the moon, on the surface of the moon, G will be bigger or smaller compared to the Earth? Smaller, right? When this is smaller, of course T will be bigger. Okay, so the answer here will be increase, just like that. Okay. Okay. Alright. So I will try to record another experiment after this. Okay, you watch this first. If you have any question, post in the group. No need to PM me. Okay, cikgu takut cikgu overlook. If you post in the group, because I already pinned the group in my Telegram lah. Alright. Okay. All the best. Alright. Okay. Bye bye. Assalamualaikum warahmatullahi.